All right, the last proof I'll do for now is, I think I'll do like another proof at the end of the semester, but the last derivative proof that I'll do is just the proofs for the other trig functions, so tangent, cotangent, secant, and cosecant. So just reminder, the derivative of tangent is secant squared x, derivative of cotangent x is negative cosecant squared x. The derivative of secant x is secant x tangent x. And then the derivative of cosecant is negative cosecant cotangent. So I'll just prove these. These proofs are really quick compared to the derivatives of sine and cosine, because you can just use the quotient rule. By the way, I'm not proving the quotient rule, just because its proof is really similar to that of the product rule. So proof that the derivative of tangent equals secant squared. What we do is we don't have to use that definition of the derivative anymore. What we do is we just rewrite tangent as sine over cosine, and then we use the quotient rule. So I'm going to use the quotient rule here. Derivative of my numerator, which is derivative of sine is cosine, times my denominator minus my numerator times the derivative of my denominator, which is negative sine. And then that's over my denominator squared. So I end up with cosine squared x plus sine squared x because of the double negative, and then that's over cosine squared x. And then use your trig identity, this one. So cosine squared x plus sine squared x is 1. And then reminder that secant is the same thing as 1 over cosine. So 1 over cosine squared is the same thing as secant squared. And we're done. So all the other proofs work exactly the same. I mean, not exactly the same, but just like that, using the quotient rule. So for example, I'll do it on a different piece of paper. Oh, I guess I can fit some of it here. Proof that derivative of cotangent is negative cosecant squared x. We start off by recognizing that cotangent is the same thing as cosine over sine, and then use the quotient rule again. So quotient rule says we have our first derivative of our first function times, or sorry, derivative of the numerator times the denominator minus our numerator times the derivative of our denominator over our denominator squared. And so we end up with negative sine squared x minus cosine squared x over sine squared x. And then we can factor out a negative 1 here. So this ends up being negative sine squared x plus cosine squared x over sine squared x. And then this, again, using this trig identity, this is just negative 1 over sine squared x, which is just negative cosecant squared x, because cosecant is the same thing as 1 over sine. And so there's that one. I don't have room to put QED, but, and then for like derivative of secant, prove that derivative of secant x equals secant x tangent x. We, same thing. So we say derivative of secant. So secant, again, is just the same thing as 1 over cosine, right? Oops, I forgot to put derivative here. So we're finding the derivative of 1 over cosine. And once again, we can use the quotient rule. So quotient rule says take the derivative of your numerator, multiply that by your denominator, minus your numerator times the derivative of your denominator. Derivative of cosine is negative sine, and then that's over your denominator squared. And what we end up with is 0 times cosine of x. That part's just 0. And then we have negative 1 times negative sine of x, so it's a positive sine of x over cosine squared x. I'm just going to write that like this. So my numerator is just positive sine of x. And then my denominator is cosine of x times cosine of x. So I'm just writing it like this for our purposes, because we're showing that this is equal to secant of x, which is this right here. 1 over cosine of x is secant of x, and then sine of x is the same thing as tangent. Tangent is sine over cosine. And then secant is 1 over cosine. And so we prove this is secant x tangent x. And then you can do the same thing for cosecant. Derivative of cosecant x is negative cosecant x cotangent x. So once again, we'll rewrite this as a quotient. So cosecant is the same thing as 1 over sine. Oops. Cosecant is the same thing as 1 over sine, and then use the quotient rule again. So let's take the derivative of your numerator, multiply that by your denominator, minus your numerator times the derivative of your denominator over your denominator squared. 0 times sine, that's just 0. So we really end up with negative cosine of x over sine of x times 1 over sine of x. And once again, we have, so cotangent is same thing as cosine over sine. And then cosecant is the same thing as 1 over sine. And so once again, we have our proof. We're done. Of course, it's typically written like this, so I'll just rewrite it using the commutative law of multiplication. I forgot to put my x there. And now we are done. Oops. So there's my proof for the that the derivative of cosecant x is negative cosecant x times cotangent x. That's all our trig functions. And I think we've basically shown why all of the rules that we are working with derivatives. So on that first page of rules that I told you guys to memorize, we've like shown, well, I've shown why all of those, every single one of those is true, except for the quotient rule, which I'm not gonna do. I'm kind of tired. I saved all these proofs for one day, and now I'm tired. And the derivative, the proof for the derivative, for the proof of the quotient rule is really similar to the product rule proof. So yeah, and then like the other rules, like the derivative of natural log, we used implicit differentiation to find that. Same thing for like the derivative of a to the x. I'm trying to think of our other rules. Also, same thing for inverse trig functions. We just used at least one of them. We just used implicit differentiation. I think we did that for both of them, for sine inverse and tangent inverse. So all those rules on that first page of the derivative sheet, hopefully you believe that they're true at this point. Anyway, I will see you one of these days. Thank you for watching these proofs. Bye.